Okay, so we're starting the carboxylic acids, and the carboxylic acids all have this functional group here, which includes a carbonyl group and a hydroxyl group as well. The two together make it the carboxylic acid, and of course, because oxygen is more electronegative, it means we're going to have a D plus carbon and also a D plus hydrogen on there. When we name the carboxylic acids, the carbon in the carboxylic acid is always given number 1, which means if we start with that one being number 1 and we count away from that, so 1, 2, 3, 4, 5, we have pentanoic acid. And on carbon number 3, we have a methyl, so that would be 3-methyl pentanoic acid. On the other example, again, we start with carbon number 1 in the carboxylic acids. So 2, 3, 4, and then we've got another functional group here. And remember, the alcohol functional group becomes hydroxy when there is a higher priority functional group in the molecule, and the carboxylic acid is a higher priority. So we have 4-hydroxy butanoic acid. Okay, so have a go at the questions here, have a go at naming those, and have a go at naming those as well. In terms of their solubility and their melting points, well, the carboxylic acids have this OH here, which has a lone pair, an oxygen directly bonded to a hydrogen, which means we are going to that is able to do hydrogen bonding. And of course in water we've got exactly the same. We've got a lone pair of electrons and we've got an oxygen to a hydrogen here. So the carboxylic acids up to about carbon 4 are soluble in water. The thing that then eventually reduces their solubility is the length of this R group here. As that gets longer and longer, it interferes with the number of hydrogen bonds that can form, which of course then becomes insoluble. As we look at the melting points then, so the carboxylic acids, because they form hydrogen bonds, they can form hydrogen bonds with each other. Now, you need an additional diagram on here because those of you that have been coming to the Zoom meetings will know by now that the carbonyl group, the oxygen in the carbonyl group, is an exception to the rule. It can form hydrogen bonds, which basically means that it can form 2 hydrogen bonds with itself. So if I just kind of put the lone pairs on here, and if we have a look at where this can form, so we can get a hydrogen bond there and a hydrogen bond here. So again, because of that, the 2 hydrogen bonds in here makes this molecule very, very big. It's actually often referred to as a dimer, di being 2, and 2 of them joined together. Okay, and that's it for this one. We'll have a look at the acidic nature of the carboxylic acids in the next one.